This is a video key for the Part A concept check. I'm going to go a little faster here because I already have it done instead of doing it with the video. Okay, so if you want a little more, I'll try still explain just as much, but you can look at the Part B one. So we're trying to find x so that L is parallel to M. So we want these two to be parallel. So there's one of four things we can do. We can prove that corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, or that consecutive interior angles are supplementary. If we can prove any of those things, that would mean that those lines are parallel, okay? So we're going to make that happen. So we're going to find x so that the measure, or that these are parallel. If we know that the measure of angle 11, which is right here, and the measure of angle 10 are equal to those measures right there. So to know, we want to make sure that they are supplementary. Since they're same side interior angles, no matter what, regardless if L and M are parallel or not, these are called consecutive interior angles. If they're additionally supplementary, then we can say that L and M must be parallel by the converse of the consecutive interior angles theorem. So we're going to make that happen. So I want them to be supplementary. So I said right here, they're consecutive interior angles, so we want them to be supplementary because then by the corresponding consecutive interior angles theorem converse, L would be perpendicular or parallel to M. So I just made that happen. So I said measure of angle 11 plus measure of angle 10 is equal to 180. Plugged in those expressions, solve the equation. So 12x plus 20x is 32x, and then we got negative 6 plus a negative 102 is negative 108. And then add 108 to both sides, you get 32x is equal to 288. Divide that by 32, and x is equal to 9. We can make sure this is correct by plugging it back in. So a 9 times 20 is 180, and 180 minus 102 would be 78. Okay, we want to make sure this is actually supplementary. So 12 times 9 would be 108, and 108 minus 6 is 102, and 102 plus 78 is 180. So they are supplementary because this was 102 plus 78 supplementary. So that would make line L parallel to line M. For the next one, same idea. We want N and P to be parallel this time. Okay, N and P. So we are given information about angle 4 and angle 14. So angle 14 is right here, angle 4 is right here. So those are alternate interior angles. No matter what, regardless if those lines are parallel or not, they are called alternate interior angles. Or, alternate exterior angles. And so we want them to be congruent because if they're congruent, then by the alternate exterior angles converse theorem, or the converse of the alternate exterior angles theorem, those two lines, N and P, would have to be parallel. So I want them to be congruent, so I'm going to set their measures equal and then use those expressions. So 3x plus 15 is equal to 7x minus 37. Subtract 3x from both sides, and you get 15 is equal to 4x minus 37. Add 37 to both sides. 52 equals 4x. Divide by 4. X is equal to 13. So again, we can check to make sure we're right. I suggest you do, just in your head at least. So 13 times 3 is 39. 39 plus 15 is 54. So we want the other one to be 54 as well. So 13 times 7, 7 times 10 is 70. 7 times 3 is 21. So 91 minus 37. If you add up or borrow here, you get, oh, look at that. You get 54. Okay, so could you even see that? No. 54. So they're both 54. So we made those angles congruent so that N and P are parallel. All right, the next part's really important because we want to recognize what we're trying to do here. It says use the figure above to determine which lines, if any, are parallel. State the postulator theorem that justifies your answer. So in this picture above, if I knew that angle 8 was congruent to angle 11, could I conclude anything was parallel? So 8 and 11, right here, right here. Those are alternate interior angles. No matter what, regardless if these lines are parallel or not, they are called alternate interior angles. But since I know they're additionally congruent, okay, when alternate interior angles are congruent by the converse of the alternate interior angles theorem, I can conclude lines are parallel. So I know that N and P are parallel, not L and M. N and P, because those are the two lines cut by transversal L that form these alternate interior angles. So since those alternate interior angles are congruent, lines N and P are parallel. Okay. Next one, we know now that 1 and 15 are congruent. So 1 is over here and 15 is over here. These are alternate exterior angles. No matter what, they're alternate exterior angles. M plays the role of the transversal. The other two lines that the transversal is cutting are N and P. So if any lines are parallel, it's got to be N and P. So since alternate exterior angles, sorry, I keep saying the wrong thing. Alternate exterior angles are congruent, then those lines are parallel. So N is parallel to P by the converse of the alternate, I did put interior too. Exterior angles theorem, okay? I put it here too. I just always want it to be interior for some reason. Alternate exterior angles. All right, last one here. We know that angle 6 and angle 7 are supplementary, so where are 6 and 7? They're right here, okay? So since I know these are consecutive interior angles, so since I know consecutive interior angles are additionally supplementary, then by the converse of the consecutive interior angles theorem, the lines are parallel. So lines L and M this time would be parallel because those are the two lines cut by transversal N that form those consecutive interior angles. So since I know that these two consecutive interior angles are supplementary, L and M are parallel. All right, next I'm gonna, let's see, we'll do a little hiding here, okay? All right, so we've got this proof, and with these proofs, the only thing we can do to prove these theorems is use the postulate. So we can only use the corresponding angles postulate or the converse to the corresponding angles postulate. So since we're trying to find the converse of the consecutive interior angles theorem, we're going to use the converse of the corresponding angles postulate. So we want to use this information to show that it eventually leads to corresponding angles congruent, which would make the lines parallel. So if I'm given that angle 2 and angle 3 are supplementary, okay, that's my given, that's my first step. That's great. But look, I also know some other stuff. So I can see angle 2 and angle 1 form a linear pair. So I would say angle 1 and angle 2 form a linear pair. Since they form a linear pair, okay, then I know that they're supplementary. So that's by the definition of linear pair, okay? And then because they form a linear pair by the supplement theorem, I know they're supplementary. So you could really say that measure of angle 1 plus measure of angle 2 equals 180, but that's not helpful to us here because of the next step that we want to do. So we want to say supplementary. We want to use the words instead of the equation. So that's by the supplement theorem. So then the next step, since I know that angle 2 is supplementary with angle 1 and 2 is supplementary with angle 3, then angles 1 and 3 must be congruent by the congruent supplement theorem. Since 2 is both supplementary with angle 1 and angle 3, then angle 1 and angle 3 must be congruent. Okay, that's our congruent supplement theorem. And then if I know that angle 1 and angle 3 are congruent, those are corresponding angles. So since corresponding angles are congruent, the lines are parallel, and that's by the converse of the corresponding angles postulate. So I can conclude that lines L and line M are parallel. Okay, so for the back, I explained these constructions on the other one, so you can go to the other one to do it. But remember that it's because I can't really draw a line from A to this specific part of segment BC with it being perpendicular, you have to extend BC because it does say to line BC. So you want to extend and then do your perpendicular construction, make sure you mark it up. So you got to name it, put solid only from A to line BC, and then name the distance, okay? So the distance from point A to line BC is AD. And that's it.